Hello friends, welcome back to my channel Learning Physics with Bhavya ma'am. So today we are going to solve numericals of model paper 3. I already uploaded numericals of model paper 1 and 2 in my channel. So in third paper, the first question is 3 capacitors of capacitances 2 microfarad, 3 microfarad, 6 microfarad are in series. Find the effective capacitance of the combination and find the potential difference across 6 microfarad capacitor if the combination is connected to 60 volt supply. So here there are 3 capacitors. 3 capacitors of capacitance 2 microfarad, 3 microfarad and 6 microfarad which are connected in series, and the combination is connected across battery of voltage 60. Battery of voltage 60. Okay. So how to calculate effective capacitance of these three? So this is C1, let us consider this is C2 and this is C3. So effective capacitance of series combination is, what is the formula to find out effective capacitance? It is 1 over Cs is 1 over C1 plus 1 over C2 plus 1 over C3. So 1 over Cs is 1 over C1, that is 2 microfarad. So 1 by 3 micro 10 to the power minus 6 plus 1 by 6 microfarad. So here 6 is common. Take LCM as 6. 6 into 10 to the power minus 6 is LCM. So 2 3s are, 3 2s are and 6 1s are. Right? So therefore here let us write 6 as common. Okay. And here we will get it is 3 plus 2 plus 1 is 6 divided by 6, that is 1. So therefore Cs is equal to 1 by 1, which is 1 microfarad. I have not written microfarad here, I have just taken the number. So it is understood that Cs effective capacitance is in microfarad. So it is 1 microfarad. Within 2 steps you will get the answer like this. If you write like this, 1 by C1 plus 1 by C2 plus 1 by C3, you will get within 2 steps. You can also use this formula Cs is equal to, see, when there are 2 capacitor, we are using C1, C2 by C1 plus C2, right? If there are 3 capacitor, you can write C1, C2, C3 divided by C1, C2 plus C2, C3 plus C3, C1. Okay? So this, you can also use this relation. Now, the next question is, find the potential difference across 6 microfarad capacitor. See, when there are in series, the potential across each is V1, V2 and V3. So if I add these three, V1 plus V2 plus V3, I need to get 60 volt. And one more thing is, when capacitors are connected in series, charge is same. Each holds same quantity of charge. Let it be Q. So how to calculate charge? Charge on each capacitor is same. We know that Q is equal to CV. Let us use this relation to find out charge on each capacitor, which is same. So Q is equal to CS into V, because here total capacitance is CS into V. So that is 1 microfarad 10 to the power minus 6 into V. V is 60. So therefore charge on each capacitor is 60 microcoulomb. Charge on each capacitor is 60 microcoulomb. So then how to calculate voltage across third capacitor? So that is, we know this formula Q is equal to CV. Now we need to find out voltage across, potential difference across third capacitor. So charge is known to us. Each capacitor holds same amount of charge. Charge is known to us. C3 is known to us. Then how to calculate V3? It is charge divided by capacitance C3. Okay, so therefore V3 is equal to charge is 60 micro 10 to the power minus 6 divided by C3 is 6 micro. So micro cancel. So V3 is equal to 60 by 6 is 10 volt. So this is the answer. Okay, the next question is from current electricity. For copper, number density of free electron is 8.5 10 to the power 28 meter cube per meter cube. The resistivity is given. Calculate conductivity of copper and relaxation time. So what is given? First write down the data given, which is number density is 8.5 into 10 to the power 28 per meter cube. Resistivity rho is equal to 1.7 into 10 to the power minus 8 ohm meter. So you have to find out conductivity and relaxation time, conductivity as well as relaxation time. Mass of electron and charge of electron is given. So for that, let us use this relation. Conductivity is reciprocal of resistivity, right? So therefore it is 1.7 into 10 to the power minus 8 reciprocal. So if I calculate the reciprocal of 1.7, I'll come to know that it is 0.588. 0.588 and this 10 to the power minus 8 becomes plus 8. So this is the answer. And this resistivity SI unit is ohm meter, conductivity is ohm per meter. Ohm inverse, meter inverse. Okay, ohm inverse, meter inverse. And what is the relation for sigma? Sigma can be written as n e square tau by m. So using this we can write tau is equal to sigma m divided by n e square. So tau can be written as, this is tau, Greek letter tau is sigma. Sigma already we calculated 0.588 into 10 to the power 8. Mass of electron is given, which is 9.1. Mass of electron is 9.1 into 10 to the power minus 31 divided by number density is 8.5 into 10 to the power 28 and charge of electron is 1.6 into 10 to the power minus 19 square it. So first you multiply these two numbers and you will get the answer. Divide that answer by 8.5 once and again after getting the answer divide that by 1.6 one time. You will get the answer. Divide that by 1.6 again. So you will come to know that it is 0.2459 and the power is minus 10 to the power minus 13 second. So relaxation time is second. Okay, this is the answer. Is it clear, student? So first multiply these two numbers. You will get one answer. Divide that by 8.5. So you will get one answer, right? Divide that answer by 1.6. Again, answer divided by 1.6. You will get this number. And here you might add the powers. Okay. Minus 19 into 2 is minus 38. Minus 38 plus 28 is minus 10. When minus 10 comes to numerator, it becomes plus 10. Plus 10, 8 is 18. Plus 18. Plus 18 minus 31 is minus 30. Yes? Okay, the third question is from AC, alternating current chapter. A resistor of 50 ohm, pure inductor of 250 millihenry and capacitor are in series in a circuit containing an AC source of 220 volt 50 Hz. In this circuit, current leads the voltage by 60 degree. Find the capacitance of the capacitor. So first let us write the data given. Resistor R is equal to 50 ohm and inductor L is equal to 250 millihenry. Capacitor we need to find out. So what is the capacitance of the capacitor? If source having RMS voltage is 220 and frequency 50 Hz and current is leading the voltage by 60. current leads the voltage. Then what is the phase difference? Phase difference is given as 60 degree. Current is leading the voltage that in capacitive circuit, right? So that means XC is greater than XL. XC is greater than XL. So if I consider the phasor diagram, so we know that in phasor diagram, here I have taken VR, then current is also along this direction, right? And VL is in this direction, and here there is a VC. So XC is greater than XL means VC is greater than VL. So that means here let us consider VC somewhere here, VC. And if I subtract this, VC is greater than VL means we will get the resultant as VC minus VL, which will be along the direction of VC. So VC minus VL is somewhere here. Now you have to add these two, VR and VC minus VL. Then resultant is acting along the diagonal. So this is resultant velocity, resultant voltage V. Okay, resultant voltage V. And angle between current and resultant voltage is phi. That is 60 degree. Is this clear for you? Okay. Now, how to write VL? VL can be written as IXL, VC is IXC, and V is equal to VR is IR, and V can be written as IZ. Is this clear? So then how to write tan of phi? Tan phi is opposite. So this is opposite, right? So opposite is parallel to this one. So that is VC minus VL. VC minus VL divided by adjacent, that is VR. So here VC is IXC, IXL, and VR is IR. So therefore we can write tan phi as XC minus XL divided by R by cancelling I. Okay, this is a relation for tan phi. Now the question is to find capacitance, right? So for that, first let us calculate XL. XL is omega L, that is 2 pi f L. So XL is 2, pi is 3.14, f is 50, L is 250 into 10 to the power minus 3. So here 2 into 50 is 100, or you can also write like this, 2 into 250 is 500. 500 into 50 and into 3.14, multiply everything, so you'll come to know that it is 78.55. After multiplying, you'll get it as 78.55 ohm. Okay, so what to do? Multiply 2.2 into 3.14 into 50 and into 250, then you'll get one number, divide that by 1000. Okay, divided by 1000 gives 78.55 XL. Okay, XL. But we can't find XC because C is not known to us. C we need to find out, right? So then how to calculate C? So let us substitute that here in this relation. So that is tan phi. So let us write phi value. Tan of 60 degree is equal to XC is unknown for us, keep as it is. XL is known for us, so that is 78.55 divided by R is 50. Then go through tangent table. Tan of 60 degree, you can check tan 60, so it is 1.732. 1.732 or root 3 or 1.732. Now multiply by 50, cross multiply. 50 is XC minus 78.55. So multiply this, you will get 86.6. 86.6 and bring this term this side, so it becomes plus 78.55, that is equal to XC. Or XC is equal to, after calculating, after adding these two numbers, you will get 165.15 ohm. 165.1 is 165.15 ohm. Now substitute that here. Okay, so then after calculating all this, see xc we came to know it is 165. Now let us use this relation. Xc is equal to 1 by omega c, right? So cross multiplying, c is equal to 1 divided by omega into xc, omega into xc, right? So that is omega is 2 pi f, 2 pi is 3.14, f is 50 into xc is 165.15. Now multiply. 2 into 50 is 100. 100 into 3.14 is 314 into 165.15. Multiply these two numbers and take reciprocal. So you will come to know that C is 19.3. 19.3 microfarad. So this is the answer. If you are good at maths, you can solve easily, right? So you should remember some numeric formula, suitable formula, and if you are quick in maths, you can solve quickly. Okay? Yes. First numerical is from first chapter or second chapter. Second numerical is always from current electricity. As we observed in all the three papers, second is from current electricity. And third is from ESC chapter. So if you are thorough with any three chapters, then you can answer two questions. Okay. So either you thorough with the current electricity and ESC chapter, or you have to thorough with any three chapters, then you can answer two questions easily. Okay. So here in third paper, instead of ray optics, they have given the question from dual nature. So we are going to discuss that later. Now, when light of wavelength 400 nanometer is incident on one photosensitive surface. Here we are having one photosensitive surface. The light of suitable wavelength is incident on a photosensitive surface. This is a metal surface. Then what happens? So there is a photoelectric emission takes place. So stopping potential for the photoelectrons emitted is found to be 0.96 volt. That means if the wavelength is 400 nanometer, then stopping potential is, let us write, stopping potential is V0, right? Stopping potential is V0. So for first one I'll write V01, that is 0.96 volt. If I change the wavelength, so when light of wavelength 500 nanometer is incident on a same surface, incident on same photosensitive surface, so wavelength changes, then stopping potential also changes to V02, that is 0.34 volt, 0.34 volt. Now calculate Planck's constant. H is how much? So we already know Planck's constant is a constant number 6.63 into 10 to the power minus 34 joule second. We need to get this number, right? We have to get this number. So for that, speed of light and charge is given. Okay. So how to calculate? First thing is kinetic energy, maximum kinetic energy of electron is E into V0. The relation between maximum kinetic energy of electron with the stopping potential is this one. Okay. So this is nothing but maximum kinetic energy and this is a potential energy. Okay. Stopping potential. This is a anode potential. Anode potential into charge is nothing but potential energy. Right. So this relation we know. And according to Einstein, how to write this? Kinetic energy, maximum kinetic energy is equal to energy of incident radiation minus work function. See, work function is same for given metal. Okay, whatever be the radiation incident on the surface, right? Even if you change the wavelength, work function remains same. For a given metal, work function is same. What is work function? It is a minimum energy required to remove an electron from the metal surface. So this work function is constant for given surface, right? So let us use this relation. For that, how to write this kinetic energy? It is EV naught, whereas energy E is equal to H nu. this can also be written as hc by lambda. Let us use that relation, hc by lambda minus w. So let us first write, for first wavelength it is EV01 hc by lambda 1 minus w, and for second one it is EV02 hc by lambda 2 minus w. W is same, work function is same. So therefore, let us subtract now. So it is EV01 minus EV02 is equal to HC is common. So W get cancelled while subtracting, W and W cancel. HC is common. Remaining is 1 over lambda 1 minus 1 over lambda 2. Okay. So now E is common, take it outside, then stopping potential is given, that is 0.96 minus 0.34. That is equal to H into C. Keep as it is, H into C. Now substitute 1 by lambda 1 is 400 nanometer. So let us write this. Nano means 10 to the power minus 9. When it comes to numerator, it is plus 9. Minus lambda 2 is 500. 10 to the power plus 9 goes to numerator. So here 400 into 500, you take LCM of this, and before that E into 0.96 minus 0.34. Say 6 minus 4 is 2, 9 minus 3 is 6, 0.62, 0.62 is equal to HC into, let us simplify it further. So here if you cross multiply, 500 minus 400 is 100 into 10 to the power 9 in the numerator divided by 5 fours are 20 and write 4 zeros, 2020. Okay, this is clear for you? I have taken LCM, so I multiplied these two numbers as a LCM. 4 5s are 20, 0000. Okay, and cross multiplying here, 500 minus 400 is 100. Now cancel these two zeros with these two zeros. Okay, two zeros get cancelled. Now in next step you cross multiply this, that is 0.62 into 2000, 1 2 3, how many zeros are there? Yes, 2000 is equal to HC by E. E comes to denominator. Is this clear for you? And 10 to the power plus 9 is there. Keep as it is. Is it clear? Okay. So in next step, I'll multiply these two. 62 into 4. 2 2s are 4. 2 6s are 12. So it is 120. 1240. Right? After multiplying, I'll get 1240. That is equal to HC by E into 10 to the power 9. So we need to find out H. So rearrange for H, that is 1240 cross multiplying with E divided by C and 10 to the power 9. Now substitute all the data given. So E is 1.6 into 10 to the power minus 19 divided by speed of light is 3 into 10 to the power 8 into 10 to the power 9. So in a calculator, first multiply 1240 with 1.6. You will get one number. Divide that answer by 3. Then you will come to know that the number is 661.33 into 10 to the power. Is it clear? 10 to the power. Say 9 plus 8 is 17. When it comes to numerator, minus 17. Minus 17 plus 19 is minus 36. Okay. Now let us shift the decimal point. So here I'll shift to 1, 2. Okay, left side. So if I shift the decimal point to left side, so that is 6.6133. Okay, 13 into 10 to the power. See, 2 is there, 6.6, 600. So if I write 6.6 means there is 100, right? 10 to the power 2. So here 10 to the power minus 36 plus 2 is minus 34. Minus 34 joule second. So this is the answer. Okay. And don't worry about the third digit. So here first two digits are enough. 6.6. Nearly. We are going to get the answer very close to that. So 6.61, 3 10 to the power minus 34 joule second is the answer. Like this, I have solved all the 4 questions of model paper 3. So dear students, I have solved numericals of all 3 papers, model paper 1, 2 and 3, and uploaded in my channel. Please watch it and share with your friends. So if there is any questions to be asked, if you have any questions, if there is any doubt, please comment below. And if you like my videos, like, share and subscribe my channel. Thanks for watching.